Well, hello there. It's Ms. Becky again. And today I'm going to be giving you a short lesson on the trig ratios of sine, cosine, and tangent. That is not sin. It's abbreviation for sine. Okay, and you guys might have seen something like this before. And if it's a refresher, this is how you're used to seeing it, is that the sine is a ratio of the opposite leg of the triangle to the hypotenuse. And then we'll go over which one is which in just a second. And the cosine is a ratio of the adjacent leg to the hypotenuse. And the tangent is a ratio of the opposite leg to the adjacent leg. And the way that a lot of people like to remember it is, oops, not like that. Not like that. Okay, so it's toa. So what do you do when you have an ingrown toenail? You guessed it, you're gonna SOHCAHTOA for an ingrown toenail. Got it? Okay, well now you have some medical advice to go along with your trigonometry. All right, so this one is asking for the tangent of angle R. So it depends on where you're standing. Like if you were standing in this triangle right here at angle R, you would be looking for the opposite leg as a ratio to the adjacent leg. Opposite leg is just going to go straight across the street. That's the opposite leg. So that one is 45. Now the adjacent leg, the word I like to think for adjacent is, sometimes this makes a little bit more sense, means adjoining. So joining. So which leg here is, you only have two legs. You have two legs and a hypotenuse. So this is the only other leg that is actually joined to the angle there. So that leg is 28 units long. And then you would look at this ratio and see, can it be reduced? And if it can't, then you just put that in and you are good to go. Okay? Now, let's see, the next one. And again, if we were looking down here at this angle, let me do that in a different color. If I asked you for the tangent of angle Q, then everything changes. This would be the opposite leg, and this would be the adjoining leg. Okay, so it depends on where you are or what angle you're talking about. All right, the next one. We want the cosine of angle E. So this is the angle we're talking about. Cosine is the adjacent, so it's going to be, this leg is adjacent or adjoining, so it's going to be 8 over the hypotenuse, and the hypotenuse is 17. And that one cannot be reduced either, and there you go. Now sometimes, depending on what you're doing, like if you're taking the ACT, sometimes you might see these, as you know, you can turn a fraction into a decimal by dividing the numerator by the denominator, but that's not what IXL wants on this one. Okie doke. Now we're looking for the cosine of angle C, this one right there. All right. But we have a problem because this one doesn't have a measurement, right? What do you think we should do? Anybody? Well, I'm sure you guys remember the good old Pythagorean theorem. A squared plus b squared equals c squared. Now, the a squared and the b squared, the legs a and b are the legs. And the hypotenuse is always on one side by itself. So it's the one that we fill in for c. So we'll just fill in what's missing here. Okay, it doesn't matter. Well, we've only got one leg, so I can say 30 squared plus the other leg we don't know, so we'll call it b squared, equals, the hypotenuse is 34 squared. Okay, if you do the math, this is 900 plus b squared equals 1,156. All right. Now the next thing, we want to solve for what this leg is. So we're going to subtract the 900 from both sides. And hopefully you line that up a little bit better than me. And what we're left with on this side is b squared. And over here, we have 256. Now, what we did is we blew the size of those up by squaring them, because you notice they got really big. So we don't want to know what that is squared. We want to know what it is unsquared. So we'll take the square root, take the square root. So b, I'll do it over here. B has to equal 16. So sometimes you're going to have to find that length of that leg. Now we can find the ratios. Okay, so we're looking for the cosine, which is the adjacent over the hypotenuse. So the adjacent leg is 16, and the hypotenuse is 34. But when we're looking at this, we do know that this reduces. And I will show you just a little quick trick. I always like to show people what your calculator does, because if you're taking an ACT or if your brain is just fried at some point, it just helps you to be sure that you have gotten this reduced all the way. So we know that a fraction is just a division problem, right? So we just divide it, but that's a decimal. We want to go to math, and then fraction is highlighted. So we'll hit enter again, and it spits out that fraction in the reduced form. Isn't that cool? Cool beans. Because at this point, obviously you guys know how to divide and reduce fractions, but everybody needs a little help now and then. Okay. Now for this next one, I'm going to get rid of some of this Sokatawa. Here, we'll get rid of this one. Okay. Again, we have a leg that is missing. So we have to use our Pythagorean theorem. So it's the square root of 33, and it's that whole thing squared, plus b squared equals the square root of 66 squared. Okay, again, it's the hypotenuse that has to be on this side that's alone, or standing in for C. Now, when you square a square root, it just turns into that number. So this is what we have. Not too bad. Okay, so we're going to subtract the 33 from both sides. And that's going to leave us b squared equals 33. All right. Again, we don't want to know what b is when it's squared. We want to know when it's not. So we will take the root. So b equals the square root of 33. All right. So we know that this leg is the square root of 33. Okay. So now we need to find what they're asking us for, which was the tangent of angle S. And that was this one right here. Tangent is the opposite leg. So it's going to be the tangent of angle S is the opposite leg, which is square root 33 over the adjacent leg, which is also the square root of 33. Okay, what do you suppose that simplifies to? You're right, 1. Because anytime you have something on the top, something on the bottom that is the same, it equals 1. I don't care if you have an elephant in the numerator and an elephant in the denominator, it equals 1. So that's all that you have to do for this section for trig ratios of the sine, cosine, and tangent. And just beware that bill for the SOHCAHTOA for your next ingrown toenail. That bill will be in the mail. So until next time, this is Miss Becky signing off.